Hi there, this is a video about isosceles triangles. And in an isosceles triangle, what we know is that two sides are congruent. And in addition to that, two angles are also congruent. So let's draw a picture. Now here's a picture of an isosceles triangle. Now what I'm going to do is I'm going to label this as point D up here, point D down on the left, and point F on the right. So I've got triangle DEF. All right. And here's what I know is that two sides of this triangle are congruent. So I'm going to come in here and label DE as congruent to DF. All right. So let's write here that DF is congruent to DE. All right. The other thing I know is that we have two congruent angles. And those angles are always down here, and we'll call those the base angles. So what I can then say here is that angle E is congruent to angle F. Now this is always going to be the case with an isosceles triangle. If you have two congruent sides, then you're going to have two congruent angles, and vice versa. If you know that you have two congruent angles in a triangle, you know that their opposite sides are going to be congruent as well. All right, now the other thing I want to talk about here is the fact that these two angles down here, angles E and F, are called the base angles. All right, and I like to think of the base angles as like the bottom angles. Now you can rotate this and move it around so that these two angles aren't on the bottom, but we typically call them the base angles. Now the other angle that we have is called the vertex angle. Okay. And so understanding the difference between the base angles and the vertex angles is really important. So now this leads us to what's called the isosceles triangle theorem. And that states that if two sides of a triangle are congruent, like we have here, then the angles opposite those sides are also congruent. Okay? And this can work both ways, given that two angles of a triangle are congruent, then their opposite sides are also congruent. All right, so let's look at an example. And in this example, it says calculate all the angle measures. All right, so determine what angle A is, what angle B is, and what angle C is. All right, and so here's what I know. Given this triangle and given this picture, we're given that angle side length AB is congruent to side length AC by these tick marks. Okay, so from that and using the isosceles triangle theorem, what we can conclude now is that angle B is congruent to angle C. Now, in order for us to figure out what these are, we have to solve for x. And so we set up an equation solving for x, and because these two segments are congruent, what we can do is just set these two parts equal to each other. So I'm going to set 4x plus 9 equal to 8x minus 15. And if we solve this equation for x, I'm going to subtract 4x first from both sides, move that over, and I get 9 is equal to 4x minus 15. Add 15 to both sides, and you end up getting 9 plus 15 is 24 is equal to 4x. Divide both sides by 4 and by 4, and we get that x is equal to positive 6. So now remember what we're trying to do. We're trying to figure out all these angle measures. So what we can figure out, we can for sure figure out angle B, all right? And that's just 4x plus 9. So 4x plus 9. I want to substitute 6 in for x of that expression. So what I can then say is that angle B is equal to 4 times 6 and then plus 9. So that's going to give us 4 times 6 is 24 plus 9. So angle B is equal to 24 plus 9. So then we get that angle B is equal to 33 degrees. All right, so we figured out what angle B is. Now, because we know that angle B is congruent to angle C, I can automatically come in here and say that angle C is also equal to 33 degrees. And I don't have to do any math. Now, you can certainly plug in 6 into this expression and get that angle B, or that angle C is going to be 33 degrees. Now we've got to figure out what angle A is. All right, so here's what I'm going to do. I want to set up an equation to figure out what angle A is. If I take angle B plus angle C plus angle A and add all those angles up, I can get 180 degrees. All right, now I already know that angle B and angle C are equal to 33 degrees. So I'm going to do 33 plus 33 plus angle A is equal to 180 degrees. So now in the next step, combine our like terms, and we get 66 plus angle A is equal to 180 degrees. Now if I subtract 66 from both sides, that will solve that equation for angle A, and we're going to get that angle A is equal to 116 degrees. So what we've done is we have solved and figured out what angle A is, what angle B is, and what angle C is. All right, and that's the kind of thinking that's required to solve some of these or answer some of these questions about isosceles triangles. All right, the next thing I want to talk about is something that's special with the vertex angle. Okay, and so what I know is if I have this triangle XYZ, and let's call it an isosceles triangle and say that XY is congruent to YZ, then because of that information, I automatically know that angle X is congruent to angle Z. Now, what I want to talk about is this extra vertex angle here. Now, what I can do is, what's unique about an isosceles triangle is that if I come in here and I find this point here, which we'll call W. Now, what W does is W is the midpoint of this bottom length XZ. So a midpoint, remember, cuts this in half. So XW is going to be congruent to WZ. Now, if I draw a perpendicular line from point W all the way to the vertex, I create what's called a perpendicular bisector, all right, which we've talked about. And that's something that cuts a line in half and makes a 90-degree angle. And not only does this perpendicular bisector cut this bottom part in half, but it also bisects the angle XYW and makes that congruent to ZYW. All right, so what we know is this, and that's that segment WY is a perpendicular bisector to XZ. All right, so now what I can conclude from that is that angle XYW is congruent to angle ZYW, all right, and that our vertex angle here has been bisected. All right, now what I've also done is I've taken this big triangle and I've also cut it into two triangles. So, you know, this angle, all of these three angles will add up to 180 degrees along with these three angles as well. So there's kind of a lot of different problems and things that you can set up, but if you know all the properties of an isosceles triangle, then you can, you know, solve these kinds of problems that are given to you. Now, a special kind of isosceles triangle is called an equilateral triangle. And what that means is that all three sides of this triangle are congruent. And then all three angles are going to be congruent. Now, the one thing I know about this is that, you know, from this, because all three of these angles are congruent, and they all add up to 180. If you take 180 and you divide it by 3, each of these angle measures is going to be 60 degrees. And this is always the case with an equilateral triangle. Now you can come in here and you can take a point from your top and extend it down and make a perpendicular bisector down here, and you're going to have the same property. All right, but the difference is that each of these angles inside of here are going to be 30 degrees. All right, and this is going to be the case for every single equilateral triangle, and we'll talk a lot more about a 30, 60, 90 right triangle that is created within an equilateral triangle. That's all I have for this video. We'll talk to you soon. Thanks. Bye.